Hello everybody, today I will be taking up the boolean algebra chapter, which is the second chapter of the curriculum. So, as you can see on the other half of the screen, you can have the notes along with that. So, look at the introduction there. So, what is boolean algebra? Here the name boolean itself specifies that we are dealing with the binary number system. So, boolean algebra is a algebra that is dealing with the binary number system. So, it is mainly used in the circuits wherein we have to design the logical circuits in the processor of the computer. We require this boolean algebra, and these logic gates, the third point says the same. The logic gates are the main building blocks of the computer processor, and then this mainly the boolean algebra deals with only two variables, that is either 0 or 1, that is either true or false. The true value is for 1 and the false value is with 0. And mainly this the name boolean algebra has been derived from the mathematician named George Boole, and he is also considered to be the father of symbolic logic. So, this was just a small introduction. We will have to remember this much, that boolean algebra is the algebra that is dealing with the binary number system, which is having only two variables, that is either 0 or 1, wherein 0 corresponds to false and 1 corresponds to true. Next we have binary valued quantities, that is variables and constants. So, what are those binary values? So, those binary values are nothing but 0 and 1. Look at the first point there. The variable used in the boolean algebra or a boolean equation can have only two variables, that is either 0 or 1. Suppose in every day also we make, in our day to day lives also we make use of boolean algebra. Like we get ready to the college in the morning and we decide, do we have to go to the college or not? We are making a yes or no decision. Like we have to take this book, or which book we are supposed to take, or do we have to take the umbrella or not? So, we make certain decisions. So, a sentence which is determining to be either true or false, such statements are called as logical statements, which is there in the second point. Please look at the second point there. A sentence which can be determined to be either true or false are called as logical statements or truth functions, and the value, whether it is true or false, those are called as truth values. And next, these values must be stored in some of the variable, and those variables are called as variables or binary valued variables. Then the decision which we take of the sentence, that is, sentence says we have to go to the college. So, we take the decision, it is yes or no, that is either true or false, and this decision is called as the binary decision. This is how we relate the boolean algebra in our day to day life. Next topic is the truth table. So, what is a truth table? Truth table is nothing but a mathematical table which will have the logic, which is used in logic to compute the logical expression with the values. Like we will have values here. Look at the definition there, the first point. A truth table is nothing but a mathematical table which is used in logic to compute the functional values of a expression. Suppose I have an expression f is equal to x into y, that is x and y. I am having the possible values here 0, 1, y value can be 1 and 0. If I am taking x and y, 0 and 1 means it is 0, because I am saying and. You will understand this with the next example. 0 and 1 means I will have to have both the values true. Suppose I am having 0 here and 1, 0 and 0 will give the value 0 itself. 0 and 1 will also give the value 0, because I am saying and, which means both the values must be true. Here 1 and 0, that will also give the value 0, and 1 and 1 means the value will be 1. This is how a truth table will function. So, we just have to remember this much. Truth table is a mathematical table which is used in logic to compute functional values of an expression. So, I repeat, a truth table is a mathematical table which is used in logic to compute the functional values. These are the functional values of expression. So, next point is, a truth table is a table whose columns are statements and rows are the possible scenarios. That I will be explaining it with an example. We have an example on the Word document also. That is meals, that is an example, meals wherein Ram prefer Ram prefers rice and roti. See the point there, and. It means that there must be rice also, there must be roti also. Only then the meal will be fulfilled. So, we shall take the meal as a variable y. Ram preferring rice to be taken as A. Ram preferring roti to be taken as B. So, this is the value. So, we can write this statement as y is equal to A dot B, where dot is the symbol for and. I am putting up a truth table for that. A, B and Y. Look at the table there. Ram prefers rice is the first point. Next, Ram prefers roti, and this is the variable for meal. So, if at all Ram doesn't prefer, if is not, there is no rice and there is there is no rice and there is no roti, then what happens? Will the meal be satisfied? No, that is false. And if there is no rice but there is roti, is the meal satisfied? No. Again the meal value will be false. The same way, there is rice but there is no roti, then also the meal is not satisfied. If there are both, there is rice and there is roti, only then the meal is satisfied. This is just an example. You can have this with the variables. That is, we have A, B and Y. 0 and 0 is always 0, 0 and 1 is 0, 1 and 0 is also considered to be 0, 1 and 1 is considered to be 1. That is what is there in the notes there. Please look at the notes while I am teaching you, because that will be of more helpful. Next, if result of any logical statements is always true. So, this column is the result column. If it is all false, when we do all the calculations and we get all the values to be false, and such statements are called as fallacy. Such expressions are called as fallacy, and if they all are true, then it is called tautology. If all the expressions are true, all the values of an expression resulting is true, then it is tautology, and if all the values of the expression is false, then that is called fallacy. Next, we shall go to the logical operators. As I told, in Boolean algebra, we will be having many values to be calculated, that is only with the two variables, that is 0 and 1. So, if we want to do some operations on them, we will obviously need some of the operators. Like we have algebra, in the normal algebra, we have many variables like that and many numbers also. Along with that, we will have operators like plus, minus, multiplication, division, the modulus and all that. So, to calculate or to do some calculation with the Boolean numbers, or that is binary number system, we require some operators, and those operators are not operator or operator AND operator. So first we will get into the NOT operator. The NOT operator is a unary operator, as in we have binary operators and unary operators for the normal algebra. The same way we have unary operators and binary operators. Here NOT operator is a unary operator wherein it will act on only one operand. You will have only one operand and one result out of it. We don't make use of two variables there. The operation which is performed by NOT operator is called complementation. As we have addition and subtraction, here we call it as complementation. The operation which is performed by the NOT operator is called complementation. So the NOT operator, for this we have a symbol, that is bar. We make use of the symbol bar. Suppose we have a variable x and complement of this value is taken to be as x bar, or also you can call it as x dash. You can have x or x dash. So what will happen if the value of x is 0 and the x dash value will be 1? Just the opposite of it. If the value of x is 1 and the x dash value will be 0. Since we have only two numbers, either 0 or 1, if the value is 0, then the value will become 1. If the value is 1, then the complement of x will be 0. This is about the NOT operator. Next we have the truth table for this. Truth table, as I told before, it's just a mathematical table which is used in logic, wherein an expression is expressed in terms of values. The value for x, the possible values for x is 0 or 1, any two values we have. Then next x bar, that is if the value of x is 0, then it is considered to be 1. If it is having value 1, then it will be changed to 0. You have the truth table and also the Venn diagram. Venn diagram, if this is considered x, if this much part is considered x, leaving out this, the rest of the thing is x dash. This much part is called x, then the rest of the thing other than x, whatever values are there except this x, that is to be considered to be as x dash. Next we have OR operator. Let us come to the next operator, that is OR. So this OR operator is a binary operator wherein it requires two operands. This operator, it is having the name logical addition. We don't simply call it addition because it is not mere addition or like algebra. It is like 1 and 1 is 1 only. So the same way we call this logical addition because 1 plus 1 is considered to be as 1 only because there is no value 2. Next, the symbol we use for it is plus. The plus symbol is used for the logical addition. We can also call it as, like if we are using x plus y, you can read it as x or y, or you can also write like this, x or y, you can write like that also. Next we have the truth table for OR. Unlike the NOT operator, we will have to have two variables, x and y, and the result of it, x or y. Suppose we'll take the possible values. The possible values can be 0, 0, 0, 1, 1, 0, and 1, 1. We can take the result to be as 0 plus 0 also you can consider the binary addition. 0 plus 0, 0, 0 plus 1, that is 0 or 1, 1, because I am not telling and, I am not telling both must be there, I am telling just or. If I am considering the previous example, if it was Ram prefers rice or roti, if any one is there also he is satisfied. But when he says rice and roti, it means that he wants both. Only when both the items are there, then he is satisfied. Here I am taking the value or. So 0 or 0, it is 0 only. 0 or 1, 1 is there, so the condition becomes true. 1 or 0, again the condition becomes true. 1 or 1, it means 1, because both are there and the condition is satisfied. This is about the or operator. Next, look at the notes over there. There we have the Venn diagram for it. There we had only one variable, so I had taken only one circle there. Here we have 2, because this is the value x and this is the value y. So or means what? Anything which is there in x, or if it is in y. It can be in x, it can be in y, and it can be in both. So the whole thing, whatever is there in x, y, both together, that is the or operator. It is not that we have, there must be only which is there in x and y. No, we are saying x or y. The things must be there in x or it must be in y. Next operator is AND operator. So this AND operator is one more, the third operators in the logical operators, and this is called as logical multiplication. It is a logical multiplication, because we will understand with the truth table. So this is binary. Again, this operator is a binary operator which requires two operands. I am taking the example x and y, and we have the symbol for that is dot. I don't know whether you call it as point or what, you can call it dot. 0 and 0, there is nothing and nothing, which will result into nothing. 0 and 1, I am telling I want both. This one is not there, false. 0, there is only one. Will my condition be satisfied? No, that is 0. Again, I have x value, but I don't have a value with y. What is my condition here? And means both of them must be there. Again, the value goes 0. 1 and 1, where we have both. I had asked for and, so it means that both the values must be there, so it is 1. So this is the truth table for AND operator. Next we have the Venn diagram. Venn diagram, the same way, we have x value and we have y value. The part of x and y variable wherein both are there. See, in this part, it is having some value of x also, some value of y also. So this part is considered as the x and y operated values. This much, only this much part is considered. Not these are not the values of x and y, because it is having only x values here and it is not having any y value. So the part wherein it intersects, the x values and the y values both are there, and that part has been the result of x into y. So this was about the logical operators, not, or, and. So next we shall get into the higher level out of it, wherein we are evaluating a boolean expression. How do you evaluate a boolean expression? Suppose expression, what do you mean by expression? Some values are there, x into y plus x plus z, that is equal to f. This is an expression or an equation. So how do you evaluate that? So look at the first step there. If we want to create a truth table, what we have to do? We have an expression here. This is the expression we have. The first step is there. Look at the first step. Determine the number of variables. If there are n variables, then we will have to have 2 to the power of n rows. So how many variables do we have in our expression? We have an expression x, we have a variable y, in our expression we have a variable x and we have a variable y, only that. So we have got 2 variables in our expression. Then 2 variables means what? Then how many rows must be there? 2 to the power of n. What is the value of n? 2. So 2 to the power of 2, which means I will have to have 4 rows. Suppose I had x, y, z equal to f. X and y plus x or y plus x and y and z, and that is equal to my result. Here I am having 3 variables. I have a value variable z, I have a variable y, I have a variable x. It means I have 3 variables and that is equal to n. So 2 to the power of 3, that is we will have to have 8 rows. So this is how you put up the truth table. We will have to determine the number of variables in the expression. The number of variables can be 2, 3, 4 or any number of variables you can have. So first we have to determine the number of variables, and the number of variables has to be taken as the power of 2. 2 to the power of 2 means I had 2 variables. 2 to the power of 3 means I had 3 variables. Next we shall do it using an example. Consider the example there. F is equal to x plus y dash. So first thing what we have to see is we have to determine the number of variables. Number of variables we have, that is one is x and one is y. So we have 2 variables, which means the value of n is 2. So 2 to the power of n, that is 2 to the power of 2, we should have 4 rows. So in our table we need to have 4 rows. So the first row will obviously be the variables x, y and possible expressions. Y dash we require. We cannot simply take x plus y dash because we have not found out what is y dash. So we shall have to take y dash, then nothing else, x plus y dash. This column plus this column, x plus y dash. Now we will have to have 4 possible values, that is 0, 0, 1, 1, 0, 1, 0, 1. These are the possible values of x and y. The next column is y dash over here. Y dash I have told you previously, the value which is the opposite of y. If the value of y is 0, then I will have to take the y dash value to be 1. If the value of y is 1, then the result is 0. If the value of y is 0, it will be 1. If it is 1, it is again 0. So we got the value for y dash also. So the next part of the expression, x plus y dash, that is x or y dash. We have to consider this column and this one, this or this, 0 or 1. 0 or 1 means what? I have got 1 at least true, so that is 1. 0 or 0, no values anywhere, so that is 0. 1 or 1, I have both. So that is 1. 1 or 0, it is or, I have at least 1. So that is 1 or 0 is 1. So this is the resultant of the expression x or y dash. So this is how you form a truth table, or this is how we evaluate a Boolean expression. Next, there are some exercise problem which is put up on the screen. You can go through that and you will have to solve it by yourself. One more there is in the second one, verify the truth table, verify using the truth table for the Boolean algebra. So how do you verify that? I am going to solve this one for you. The second exercise problem I am speaking of. Second one, A, x plus xy is equal to x. So this is the expression. We will have to prove that the column with x plus xy must be equal to that of x. So how do we do this? So recall the steps which I have told. We will have to see how many variables are there. There are two variables, one is x and one is y. So two variables means 2 to the power of 2, that is 4 rows, x, y, and each single expression we should have x, this is xy means x dot y, then x plus xy. These are the possible expressions. So I told there are two variables and we will have to have 4 rows, 0 0 1 1 0 1 0 1, x and y. I want both the values. I want both the values, only then the value will turn out to be 1. 0 and 0, 0, 0 and 1. I told and I want both the values to be there, only then the value will become 1. 0 and 1 is 0. 1 and 0, 0. 1 and 1 means that is 1. I have both the values and that will turn out to be 1. Next, x or xy. I will have to take this to x or xy. Do something like this during the exam also, so that there won't be any sort of confusions. X 0 or 0. 0 or 0, there is no value at all, that will be 0. 0 or 0, 0. 1 or 0, I already have a value 1 and that can be taken to be 1. 1 or 1, sorry, 1 or 1, it means it is 1. So now we shall compare the value of x 0 0 1 1, x plus xy 0 0 1 1. So from this we infer that x is equal to x plus xy. So this is how we evaluate a Boolean expression. When we have to evaluate, when we have both the values on both the sides, when we have to prove that LHS is equal to RHS. Next we have the basic logic gates. So these gates are very much important. In computers, these Boolean operations are mainly performed using logic gates. Without a gate, it is not possible for the circuits of the processor to be built. So what is a gate actually? So look at the definition there. A gate is simply an electronic circuit which operates on one or more input signals and it will have only one output signal. Inside a gate, you can have one or more input signals. Input signal can be one also, you can have two also, but once it passes through a gate, this is an inverter gate for OR, this will have only one input value. Why is that so? Because NOT operator operates on only one operand. That is why they have only one input signal and one output signal. So there are three types of logic gates. One is NOT gate, the OR gate and the AND gate. The same way we have logical operators, the same way we have logic gates. The NOT gate is also called as inverter gate because it will invert the value. If I am having x here and the value which comes out is x dash. So this is the symbol for the NOT gate, that is our inverter gate, which is having only one input signal and it is having only one output signal. So the definition of gate itself says that it's a gate is just a simple electronic circuit which takes in one or more than one input signals and it will give out only one output signal. Next, this is the symbol for the inverter gate, and you can look at the table also. The table I have been put previously, x and we have x dash. Since we have only one variable, the possible value is either 0 or 1. If the value of x is 0, then the value of x dash is 1. If the value of the x is 1, and the value will be 0. Next, we shall come to the OR gate. So OR gate, the symbol is, see, you cannot have only one input now. OR is a binary operator. So you will have to have two inputs here. We will have two inputs and this is the symbol for OR gate. This is the symbol for OR gate. This can be x, this can be y, and this is the resultant which is coming out. You will have two input values and only one output value. Look at the truth table there. Truth table, we cannot have only x here because we have two variables, that is two input values, x, y and 0, 0, 1, 1, 0 or 0 is 0, 0 or 1 is 1, 1 or 0 is 1, 1 or 1 is 1 again. So this is the truth table with two variables. If we have three variables also, we can have the logical operation done. You can look at the notes over there where we have x, y and z. We have three variables and there is the resultant. If any one of the value among x, y and z, if there is any one of the value 1, then the resultant will be 1, because I am saying this or that or the other one. We can have the example. You can have your physics class or you can have your chemistry class or you can have your maths. If I am saying or in between each of the variables there, physics or chemistry or mathematics, what does it mean? It means you have to bring all the three? No, it means any one of them is positive, or if you are getting any one of the book, that is the condition is satisfied. If I am saying physics and chemistry and mathematics, it means what? You will have to bring all the three. If one is missing also, then the condition will go false. So this was about the OR gate, and see, you can in the notes you can see we will have two input OR gate, or we can have three inputs, we can have 4 inputs or any number of inputs, but the output will be only a single variable. Next we have the AND gate. AND gate is also similar to OR gate, wherein we will have two input signals and there will be only one output signals, and this is the multiplication of the units. So this AND gate, it is operating on two variables wherein we have the possible values 0, 0, 1, 1, 0, 1, 0, 1. So this is AND. 0 and 0 means 0, 0 and 1. I want both the values to be true, only then the value will become true. So 1 is 0 here, then I will have to have it 0. We can also remember like this, 0 into 1. So when we multiply 0 and 1, the value will be 0. 1 and 0. still we don't have both the values there, so that will the value will be 0. 1 and 1, we have both the values, so the resultant will be 1. So this is with the 2 variables. We can also have 3 variables also. You have it in the notes there, x into y into z, wherein look at the first row over there. As I have told you previously, if we are having 3 variables, then we will have to calculate it as 2 to the power of 3. That is, we will have to have 8 rows in our truth table. So the possible values can be So these are the combinations of possible values. If I am saying and 0 and 0 and 0, which means we don't have any true values, then the value will be 0. At least one must be there. This is 0 and 0 and 0. So I have told you that is logical multiplication. You simply have to multiply 0 into 0, 0, again 0 into 1, that is also to be 0 only. So always remember, in AND both the values must be there. If it is 2 variable, if it is 3 variable, we need to have all the 3 variables, only then it will be true. Here we have only one variable, the other rest of them are not there, so it is 0. Here also we have 2 inputs, one input is 0, then again it is 0. Only in the last row it will be taking the value 1. Here 1 is there is no values here. 1 0 1 0 1, no, because 1 is missing. 1 0, no. This is how it functions. Next, boolean postulates. We have, that is the most important one, the boolean postulates. We will have to prove it also, and these postulates will be helping you in evaluating the boolean expressions. The fundamental laws of the boolean algebra is called as a boolean postulates. Those are like the fundamental. Fundamental means which is the very basic laws of boolean algebra. These postulates are also working based on the 3 logical operators, that is AND, OR and NOT. So first we have properties of 0 and 1. So please look at the notes given there. First one says, if x is not equal to 0, then x must be equal to 1, because in boolean algebra we have only 2 variables, that is either 0 or 1. If the value of x is not 0, then it is obviously to be 1. Next, if x is not equal to 1, then x is equal to 0. Then the second one is the OR relation, that is the logical AND, wherein we have 0 plus, or we can say 0 or 0, that is 0, and 0 or 1. I am saying OR, it means any one of the value is 1, then the resultant will be 1, and then in the next part 1 plus 0, that is also 1, because we have one value is considered to be true and the other one is false, so we can have 1 over there. Next we have 1 or 1, both the values are there, but then it is 1. Next we have AND relation. The same way, 0 and 0, it is 0 because there is no values at all. Next 0 and 1. So it is told previously, and means you should have all the values true, only then the resultant will be true. 0 and 1, 0. 1 and 0, that is also 0 because there is only one value true. One more, 1 and 1, we have both the values true, and that is why it will result in 1. Next, fourth one, complement rules. Complementing means when the value of x is 0, it will become 1. So that is, if it is 0, then 0 dash, that is considered to be 1, and 1 dash, that is 0.